Hi there, welcome back. This is lesson 7 in unit 12. Today we're going to continue practicing with drawing and naming isomers. So if this word sounds completely foreign to you, go back to yesterday's video. We went over what isomers were and how to draw them for alkanes, alkanes with branches, alkenes, alkynes, and stuff with functional groups. Again, just like with any of these practice videos, it makes the most sense for you to try these practice questions on your own and then watch this video to help with any questions you were struggling with. Just a heads up on dates. It looks like CAS Learning number 23 is due tonight by 11:59. Just make sure that you are following any announcements that your teacher may update you with. So let's get started. Question number 1 says, what is an isomer of this compound? So again, an isomer, you have the same molecular formula, I'm going to abbreviate that, but a different structural formula. And a different name. So structure and name go hand in hand. If it has a different name, that means its structure is different, and vice versa. Okay, so the formula for this compound is C4H8Br2, and if we're going to name that, it's 1,1-dibromobutane. Again, the butane, because there's 4 carbons, ane because there's single bonds between the carbons, 1,1 because it's the location of these bromines. Yes, it's flipped. Make sure you always label them on the smallest carbon. Di means there's 2 bromines. We gave the location of both of them. Boom, you got yourself your name. Okay, so we want to find a compound that has the same formula but a different arrangement of these molecules. So if you look at choice A's molecular formula is C5H10Br2. So right off the bat, we know that the formula is different, so it can't be an isomer. But if you want a naming practice, it would be 1,1-dibromopentane. So we have that different name, but you have to have the same formula. So that can't be A. B, we have the molecular formula C4H8Br2. Okay, so the formula matches the question. So that's one check. Let's name that. And it would be 1,3-dibromobutane. So that's very, very possible to be the answer. It is the answer. Let's just continue to make sure we're 100% correct. Choice C, the formula is C4H7Br3. So we know right there that the formula is off, so it can't be that. The name is really confusing as well. If you wanted to, you could try it. The name is 1, 2, 3 tri-bromo 2 methyl propane. Now, if that's not a long name, I don't know what is. They do get longer. So, whether or not you can name that or not, that doesn't matter. But the formula doesn't match, so it can't be an isomer. And lastly, the formula is C4H8Br2. So if we could just kind of go back a second. We know the formula needs to be this, but it needs to be a little bit different. So we know A and C can't be the answers. So now we're stuck between B and D, and that's when you have to look at the names. The name for D would be 1,1-dibromobutane, and that's the same name as the question, so it can't be D. So all they did with this compound, or the original compound I should say, is just turn it 90 degrees, and that doesn't make it an isomer. It's the same thing. So that's why B has to be the answer. Number 2 says which is an isomer of 2-chloropropane. So what you should focus on is that 2. So remember, that 2 is the location of where that chlorine is. So if you wanted to make an isomer of that, all you need to do is just move that location, okay? You don't want to change the number of carbons. You don't want to change the type of bond. You don't want to get rid of the chlorine. So right off the bat, you can get rid of A and B and C, because this changes carbons, this changes the chlorine, this changes carbons and chlorine. And so the answer is D, because now that chlorine is at the first carbon instead of the second carbon. Okay. Number 3 says which is an isomer of this compound. So they gave you the condensed formula to be obnoxious. So what you would want to do is figure out what the molecular formula is. So that's C4H10O. So you're looking for an answer choice with the O2. The same thing. So you get, for choice A, it's C4H8O. Hold on. Cut this part out. Cutting. Okay, we're gonna head back to this. So, question number 3 says, what is an isomer of this compound? So this formula is C4H10O. I miscounted, sorry. It is C4H8O2. So you want to find a compound that has the same formula as that. So when you look at answer choice A, the formula for A is C4H10O. So you're off by H's and O's. That can't be right. B is C4H10O. You're off by 2 H's, so that can't be right. C is C4H10O. You're off by H's and O's. And D is C4H8O2, and that is your answer. Okay. Number 4, same kind of method. If you want to kind of combine this a little bit, our formula is C4H10O. And again, you want to find something with the same formula. So choice A is C4H10, which is, you're missing the oxygens. B is C4H10O, which matches and is our answer, but let's just keep going. C is C5H10O2, not right. And D is C2H4O2, and that's it. So these types of questions are fairly simple if you take the time to count elements. Number 5, instead of a formula, they gave you a molecular formula, they gave you the structural formula. So, same routine. Count everything up, you get C4H8O. So your answer choice needs to have same number of pieces. Choice A, the formula, if you count everything up, is C4H10O. Not right, you have too many H's. B is C4H8O2. You are missing, we have an extra oxygen rather in this case. I feel like I'm calling bingo numbers. C4H10O. And here you have too many hydrogens. And choice D, C4H8O. Yay, it matches. You've done another isomer question. Okay. Next question, number 6. It says the two isomers of butane have different. So isomers, you have the same molecular formula, but a different structure and a different name. Okay, so if you have a formula mass, if you have the same molecular formula, so remember formula mass is if you have a formula C2H4. So you have the mass of the 2 carbons plus the 4 H's. If you have the same formula, the mass is going to be the same. If you have the same formula, it's going to simplify the same way. If you have the same formula, well, you have the same formula. It can't be C. So by definition, a isomer has different structural formulas. Okay. Number 7 says two substances have different physical properties and chemical properties. Both substances have molecules that contain 2 carbons, 1 oxygen, 6 hydrogens. So they have the same formula, but different properties. That means they are isomers. Now, isotopes, it looks similar, but that's when we had, C14, C13, C12, the same element, but different masses. Can't be the same compound because it has different properties. And it's not a hydrocarbon because you have oxygens in there as well. Okay. Number 8, which two compounds are isomers? Again, you want to find the same formula, and that is choice D. Number 9, if you have two compounds that are isomers, they have to have the same percent composition. Remember, they're made of the same pieces. So you can draw multiple things with that formula, C5H12. But you can draw it differently. But it's made of the same pieces. So you still have the same percentage of carbons and hydrogens. Number 10, again, you want to find the isomer of propanoic acid. So this formula is C3H6O2. We'll just kind of combine everything a little bit. So you want to find the answer choice with that. A is C3H4O2, which is off by some elements. B is C4H8O2, which is off. C is C3H8O2, which is off. D is C3H6O2, which matches and is your answer. Okay. Halfway with the question. This one says, now we're into some drawing questions. In the space below, draw a structural formula for one isomer of this hydrocarbon. So, one thing you want to do, I think what would be easiest, is just pop this branch somewhere else. So, this formula has 5 carbons and 12 H's. So, there's a few different ways you could do it. One option is drawing it like this. I'm going to save time and not draw my H's, but I'm going to represent them with a line to show that they do exist. So that would be C5H12. So this way works. You could also draw it as this. Draw it this way because I'm running out of room. This is also C5H12. So either way works. It's up to you which one you like better. I think just making it a straight line is easier than making branches, but whatever floats your boat. Next, draw one isomer of butane. So when you're given a straight line, it's easy to just kind of pop a branch somewhere else. So you can get something that looks like that. Remember, each line represents an H. It saves time from writing absolutely every single H, because that would take a really long time and make the video even longer. Same thing. Okay, if you wanted to double check, this has 4 carbons and 10 H's, and this also has 4 carbons and 10 H's. Number 13, draw a structural isomer. Again, I like just moving a methyl group and making a branch. There are multiple options of this that you can do, but just to keep things simple, let's just do 1, 2, 3, 4, and a group right there. And then everything else is H's. That's a possibility, and there are a few more. I'm pretty sure we did this example in yesterday's notes, so you can look there for more examples as well. If you drew something and you're not quite sure if it is an isomer, you can take a picture of it, send it to your chem teacher, and ask them. As long as you have the same formula, that should be fine. So again, this is C5H12, and this is also C5 to bet 5. C5H12. Okay, number 14 gives you words that, okay, cool, no one cares. Draw a structural formula for an isomer of the product that has the same functional group. So we don't care about this either. We want to draw an isomer of this. And here we have this functional group, which is the ether, because you have 2 chains on either side of it. So when you want to draw an isomer of it, it would be easy to just take this and pop it over there. So you get CH3, 2, 3, like that. So you still have your 2 chains, you still have your ether. Now you just took one little section, pop it over to the other side. You still have the same formula. Okay, number 15. Nobody cares about this. It says, in terms of molecular formula and structural formula, why this is an isomer of this. So we don't really care about this either. It's saying, why is something an isomer? So you have same molecular formula, and when it says in terms of, you need to mention molecular and structural. So same molecular formula, but a different structural formula. So these 2 things are drawn very differently. Hexane looks like this, and then dimethylbutane looks like that. And again, it has the same molecular formula. You can count up all the C's and H's, but they have different structural formulas and therefore different properties. Okay, 16 gives you a whole bunch of stuff we don't care about. This is kind of cool though, what cyclopropane looks like. But it's saying, why is this an isomer of this in terms of molecular and structural formulas? So none of the picture, you don't need to draw anything, you don't need to know anything, except the fact you have the definition of an isomer. The same molecular formula, but a different structural formula. That's what you need. Number 17. Draw an isomer of reactant 2. So here's reactant 2. We have an alcohol functional group. So one of the tips for creating isomers with functional groups is just take the functional group and put it somewhere else. So go all Patrick trying to move Bikini Bottom. Okay. So we have the OH group on the first carbon. So let's put it on the second carbon. So if we draw it like that, you have the same formula, we just moved the OH group. Now, if you move the OH group to the other end, that would not work because it's the same compound. So, moving stuff to the middle, when you have something on the end and you move it to the middle, that's a guaranteed way to make an isomer. There are other ways, this is just the easiest way. Okay. Again, paragraph on biodiesel. Cool. Really scary equation. Cool. Imagine trying to balance that. That would be fun. Bonus question on a test you will never take ever. Okay. What is important is explain in terms of both atoms and molecular structure why there is no isomer of CH3OH. So if you were to draw this, CHHOH, see why there is no isomer. So you could say that you can't arrange the given atoms in any other combination, in any other combo to build a different structure. So here's this is methanol. There's no other way you can really build this because every H can only make one bond. Carbon can make 4 bonds, and oxygen can make 2. So based on all that information, there's no way to arrange this any other way. Number 19 says, write the empirical formula for isomer number 1. So remember, that is the simplest ratio. And the formula that we're working with is this one right, this one right there. So C6H14. How can we simplify this? Divide everything by 2. So what number goes into both of these things? 2 goes into it. And so you get C3H7. And you can't break down 7 anymore because you have to use whole numbers for your subscripts. And so that would be your empirical formula. Lastly, number 20 explains in terms of intermolecular forces why isomer 2 boils at a lower temperature than isomer number 1. So think back to forever ago when we talked about intermolecular forces. So we can say that isomer number 2 has weaker IMF. You could say and isomer number 1 has stronger IMF. So remember, intermolecular forces are the attractions in between different molecules. And so kind of how they interact with each other. So how, you interact with your family and your friends. You're not physically connected to each other, but you interact with them. So things with strong intermolecular forces, they're attracted to one another, and it takes a lot of energy to kind of break them apart and separate them. So like if you're talking in class next to your best friend, it takes a lot of energy for the teacher to get you guys to stop talking to each other. Because you're so attracted to each other, it has a high boiling point and a high melting point, because you need a lot of energy to kind of separate the two from interacting with each other. If something has weak IMF or weak intermolecular forces, the molecules are kind of attracted to each other, but it's relatively easy to separate them. So they would have low boiling point and low melting point. So having what I wrote in the box saying isomer 2 has a weaker intermolecular force, that makes sense as to why it boils at a lower temperature. It doesn't need as much energy to kind of break up that party. So that is it for today. Just make sure you are following the calendar for when CalStat learnings are due. If you have any questions, let me or your chem teacher know, and have a wonderful day.